In this live example, we're going to take a look at what is commonly called the Josephus problem, a common problem that's looked at in mathematics and computer science as a little bit of a test case for writing code. So it starts with the legend here. Flavius Josephus was a Jewish soldier, and they were fighting against the Roman army in the 1st century. And the legend is that there were 40 soldiers in his group, and they were stuck in a cave, and the Roman soldiers were outside, and they were about to be captured by the Roman soldiers. So the group decided that rather than be captured, they were going to commit suicide instead of being captured by the Roman forces. So it's a little bit of a dark problem, but they decided that instead of killing themselves, they were going to form a circle, and then they were going to have a sword, and then one soldier was going to kill the soldier next to him and then pass the sword on to the next living soldier who would do the same. And this process would keep repeating around the circle until only one soldier was left, and then he would be captured by the Roman army. So they were forming the circle, and Josephus decided that he wanted to be the one that lived. He didn't want to be killed by the sword. He would rather have been captured. So he did some calculations, he did the math, and he figured out that for the 40 soldiers, he wanted to be in the 17th position because that's the soldier that would survive this process. So what we're going to look at is a simulation that's going to go through this process, and we are going to check, is the 17th position indeed the one that would survive? So it's going to be a repeating process of a soldier getting the sword, killing the soldier next to him, and passing it on. This is the type of simulation that really lends itself to a loop because it's the same process that's going to slightly change each time but keep repeating itself. So where we want to start is just on paper or on the slide here. Instead of starting with the 40 soldiers, we want to start in a smaller scale, something that we can visualize more easily, we can do by hand. We're going to simulate it in the small scale, make sure that what we are simulating is matching exactly what we are able to easily do on paper. Then we can scale it up and then do it for the full 40 soldiers and see, now that we know our process works, how does it behave for this larger scale problem. So what we can do here is I'm going to first do a simulation just on the slide here. What if there were 5 soldiers in the circle? How would this process work? So let's assume that the soldier at position 1, he is given the sword first, so he kills the soldier next to him. We're going to go clockwise here. So soldier 1 has the sword, he is going to kill soldier 2. Right, so soldier 2 is dead, he's out of the, I'll call it a game. So soldier 1, the sword passes on to the next soldier who's living, so soldier 2 is dead, therefore soldier 3 gets the sword next. Soldier 3 is going to kill the next person in line, which is soldier 4, so soldier 4 is dead. Soldier 3 passes the sword on, it can't go to 4, 4 is dead, so it goes to soldier 5. 5 is going to kill the next person in line. Well, there are only 5 soldiers, so there is no soldier 6, so it goes back to 5, killing soldier number 1. Right, so 5 has to pass the sword on, 1 can't take it, he's dead, 2 can't take it, he's dead, so soldier 3 gets the sword. So soldier 3 kills the next person in line, well soldier 4 is dead, so soldier 5 is the next one that's still alive, so soldier 3 kills soldier 5. And at this point we have only 1 soldier left, so it turns out that for a group of 5, that the soldier that is third in the circle is the one that survives. The other 4 died in this process. All right, so just going backwards quickly, again, starting with 1, 2 is going to be killed, then 4, then 1, then 5, and 3 will be the last one left. So we already have a small test case that once we make our program, we can test it with 5 soldiers, make sure we get the same results, the same order of killing here. Then, once we're sure the process works correctly, we can go up to 40 soldiers, as long as we program this in a robust way that can work for any size group of soldiers. So in general, when this problem is studied, some people look at it with a different number of soldiers in the group. We'll do 5 and then we'll do 40. But also there might be different rules that you kill not the soldier next to it, but 2 next to you, it'll skip someone. Or 3, it'll skip, or maybe you kill the soldier and the soldier after him that's next to you. We're just going to do this more simple version where it's just the person directly, if we draw it in a circle, the person that is next clockwise in the circle from you. So again, I'll note this is a live example. I have not solved this before, so you're going to be able to go with me as I figure out a way to simulate this in the software, in MATLAB, for the group of 5, and then going up to a group of 40. So I just have the problem restated here. I'm going to do this. I'll do this as a script. I could make a function where I could give it a group of n people, and then it would give me back which is the last, what position is the last to survive. I'll just do this as a script though for this example, but I will make it robust still. So let's start with, I'm going to declare n is 5. So this is number of soldiers in the group. That way, if I do everything based on big N, what I can do then is change that to 40, and my program should still work the same way, but give me the results of what if 40 soldiers were in the group. And I'll spell this correctly. All right, so what we need to do is have a way of keeping track of what soldiers are alive and which ones are dead, so we know whose turn is next and who is going to be the next to die. So I am going to say that, I'll just call it x is 1s n by 1. All right, so x is going to represent my group of soldiers, and it's going to indicate if they are alive or dead. So I'll say that 1 is alive, 0 dead. So if I run this, all right, let's see what we have here. So x, that's my list of soldiers. So initially all of them are alive. So I'm going to have the element number, or the index, be related to the order in the circle. So this will be the soldier 1, 2, 3, 4, 5, just like we had back here in our picture with 1, 2, 3, 4, and 5. All right, so this process is going to repeat itself, so a loop is going to be useful here. We actually know how many times we have to repeat the pattern of a soldier picks up the sword, kills the soldier next to him, and repeat that, because we know that all but one soldier is going to die in this process. So really we know that, like for n is 5, it's going to repeat 5 minus 1, or 4 times. So I could actually use a for loop for this. I'll do this though with a while loop. Either method will work. I'd say anything we use a for loop for, we could use a while loop for, but not really vice versa. And typically you would want to use a for loop over a while loop, because then you can't, it's harder to get into an accidental infinite loop. But for this one, I want to use a while loop, at least for this example. So I need to keep repeating this process until only one soldier is alive. Once only one soldier is alive, the process is over. He's the survivor, and then I can see, well, which soldier is the one that survived. So a while loop, the thing I want to test is, do I have more than one soldier alive? So what test can I do to determine, is more than one soldier still alive, and I have to keep repeating this process? Well, I can look at x, and if I have it on the screen here, there are 5 1s in x. And what I'm going to be doing in this loop to signify a soldier's dead is I'm going to change the 1 to a 0. So really what's going to happen in the end is everything in x is going to be 0 except for one spot that's going to be a 1. So really what I can check here is, if I look at, one way to test it is I can take the sum of x. So let me just do it here. If I take the sum of x, it's going to add, since it can only be 1 or 0, really what the sum of x is telling me is how many soldiers are still alive. So if the number of soldiers still alive is greater than 1, I need to keep repeating this process. Once the sum of x is equal to 1, this while loop is going to stop, because the while loop is going to run as long as the statement next to it evaluates to 1. So if I run just this, it should evaluate to 1 because that statement is indeed true. And we see that it does evaluate to 1. Once this thing evaluates to 0 or false, so that if the sum of x is equal to 1, 1 is not greater than 1, it will be a 0, then it will not repeat the loop. All right, so I could have also used a for loop for this because I could test how many times do I repeat this pattern of a soldier killing the next soldier in line, because I know it's going to run n-1 times in general. So I could have done it that way also. I just decided to use a while loop here. All right, so like we did on paper, we are going to start with soldier number 1 being his turn, and he's going to kill the next soldier in line. So what we can do is initially, that means that if soldier 1 is up, they're all alive. Soldier 2 is the next one to be killed. So let's see what we can do here. So we need to kind of have a pointer that is keeping track of which soldier should be the next to die. So we know that if soldier 1 is going first, soldier 2 is going to be the one that's killed. The sword passes to soldier 3, 4 is the next one that's going to be killed. So, and then it's going to pass to 5, and then 1 is the next one to be killed. So the pattern that's going to be here is we need to find basically what's the next soldier that's alive, and then start there and then go around the circle until we find who that soldier is going to kill. So I'm going to use I'm just going to initialize k as 1, and this is going to point to soldier who has the sword. All right, so if we know which soldier has the sword, then we have to look at which soldier are they going to kill then. Okay, so on k is 1, I'm going to initialize it that way. Again, I'll note, however I'm solving this, probably not the most elegant way to do it since I'm doing it in real time, but we just need to make sure that we are able to simulate this faithfully. All right, so if it's soldier 1's turn, he has to look at who he's going to kill. So what we need to look at here is if, and actually as we go through this, I think that a while loop is actually a better way to go. We'll see in a minute. So I want to look at if, so what I'm going to do is when k is 1, that means it's soldier 1's turn. So I am going to, in this loop, search for who is soldier 1 going to kill. So what I can look here is if x of k plus 1, so again, let's imagine when k is 1, we're looking at x of 2. So initially that's 1. That is really the life status of soldier 2 right now, or the k plus first soldier. So if soldier k plus 1 is alive, so I'll make a note here. So if soldier k plus 1 is alive, that means that they can be killed by soldier x of k. All right, so how do we indicate the soldier is dead? Well, we can change their status of 1 to a 0. And just for purposes here, let's display x each time. Let me just run this. It's not complete by any means, but it's a start. And actually, let me make this a horizontal instead of a vertical vector, just so it's easier to look at. And actually, it gets stuck in an infinite loop. So if I run this, it's printing. It still says it's busy. It's never finishing because I have no way of changing k. So this is the possible danger of a while loop. I just have to control C out of it to make it stop. All right, so it killed the first soldier. That was successful, but it never did anything else. All right, so that soldier is dead, so it should go on to the next living soldier's turn. Which means that now we need to find which is the next living soldier. So really what we have to look at is, well, only living soldiers can even have a turn. So let's start here. If x of k equals 1, that has to be true for the soldier to even have a turn. because if the soldier's dead, then they can't pick up the sword and kill the one next to him. All right, so let's do this. All right, so when k is 1, we're going to go into our loop. We're going to check, is that kth soldier alive? Initially, yes. Is the person next to him alive? Yes. Then kill that soldier. But what happens when, and then we can go on to the next soldier here. So if they're alive, kill the soldier. We need a way of incrementing k, because k is going to always point to the soldier who has the sword next. So once they have killed the soldier next to them, they have to pass the sword off. All right, so pass sword to next soldier. All right, this is not going to be correct, as we're going to see, but it's the start of the idea we want to go through here. All right, so they pick up the sword, they kill the soldier next to them, and now the last step is they are going to pass the sword on. So k equals k plus 2, because we know from our little paper demo that 1 kills 2 and then passes the sword to 3. So let's just see what happens here. All right, so it kind of works. So after the first session, 1 has killed 2. So 2 is dead. That's what we match. They pass it to 3. So on the next round, 3 has the sword and kills 4, and then passes it to 5. But now we have this problem here that it's not working because we are index exceeds the number of array elements. Because if we see what happens here, it crashed out when k was equal to 5. So it's giving us an error on line 32 because when k is 5, that means that it's trying to find x of 6. But the problem is that x only has 5 elements, so x of 6 does not exist. So we have a problem here because it's going from 1 to 3 to 5. If we keep adding 2, it's going to go to, well, 6 or 7. So really what we have to look at is the way that this goes in a circle. So next to 5 is not 6, but it's going to be 1. So really what we need to do here is have a way of resetting, going back to 1. So there's different ways we can do this. We can use what's called the mod function. And basically what it does is it's going to give us the remainder of a division problem. All right, so it's mod or modulo. So why is this going to be useful? Is because if I have, like right now, my k is 5, but when I check k plus 1 here, it's going to be 6. And again, I can't do that. X of 6, it's not really the 6th element I want to check because 5 is next to 1. I need to check the first element. What I can do then is I can mod k plus 1 with 5. And what that does is it's going to give us the remainder from this division problem. So I have basically 6 divided by 5, and it gives me the remainder, which is 1. So the modulo is going to allow me to kind of keep repeating, going from 1 to 5. So really, let me do this. So I really want to always be modding these values with 5. And also here, I want to do the same thing. Now let's run it and see what happens. Must be positives. Okay, let's see. It is giving an error on line 30. If I run that, I get 0. Oh, okay, because it's giving me a problem with because it's doing 5 divided by 5, so that is giving me an issue here. Let's see what I can do. First, I can generalize this a little bit. I want to make this n. It's only 5 in this case, so I want this to work even when we have 40. So let me fix that. I'm going to restructure this a little bit here. I'm going to first check, is k greater than n? So if so, I'm going to make k mod kn. All right, so this check will always reset it so that k keeps being between 1 and 5. So that will help there. And okay, I can check here. That will make it so I don't have to do all of this. I can just say it's k plus 1. I think this will be a little bit easier to look at there. All right, it's not going to work yet, but let's see what does happen. Oh, okay, so we're still running against the same problem here that it gets to 6. All right, let me try this. I'm going to use another variable here I'll call n. So K is the soldier that has the sword, and N is going to be the soldier that he is trying to kill. So let's see if this makes it a little bit easier, or actually it might make it a little bit harder. I guess we're going to see in a second here. All right, so we're going to keep checking to make sure that K and N are always numbers between 1 and 5. All right, so who has sword? So first we want to look at whose turn is it to have the sword. So that's what K is pointing at. So we want to make sure, is x of K equal to 1? Because if not, we have to choose another soldier. All right, so let's see what we want to do here. All right. This is actually a little bit more complicated than I was expecting to put together, at least on the fly here. So we want to see whose turn is it to have the sword. So I'm going to have a while loop here that's going to keep passing the sword to the next living soldier. So while x of k is, I'm actually going to do the opposite here, not equal to 1. So k equals k plus 1. And there. Okay, so we are going to see, all right, so initially k is equal to 1. We're going to go into the loop here. We're going to check, is there more than one soldier alive? Then we're going to set k and n equal to a number between 1 and 5, so that keeps cycling here. And then we're going to check, okay, who should have the sword on this turn? So we are going to search for the next living soldier to pass the sword to. So we're going to say, well, x of k is not equal to 1. So right now k is 1. Initially, x of 1 is 1, so it's going to stop. But let's say that the kth soldier is dead. We are going to go in the list until we find the next living soldier to pass the sword to. And we're going to have the issue here that we need to also cycle this here. So I might actually need this here as I go through this. Okay, so k equals k plus 1, but let's say that we are looking at the 5th soldier. The 5th soldier is dead. We're going to have 5 equals 5 plus 1, or k equals 5 plus 1 is 6, but then we actually want to look at the first soldier. Okay, so this should find us who has the sword. Now we want to say who is the target. All right, so n equals k plus 1. So reasonably, the next target is going to be the next soldier clockwise. So I'm going to start by looking at the target being whatever the soldier is that's alive plus 1. And then again, I need a little code here to make sure it goes in a circle. But we can only kill soldiers that are alive. So while x of n not equal to 1. We're going to do the same idea to make sure that we are targeting a living soldier. So we're going to say, is the nth soldier alive? And let's actually do the same thing here. Right, so if they are not alive, so if this evaluates to false, that means that x of n was 0, we can't kill a dead soldier. So we can increase n by 1. And we can do the same idea here, that we're going to go in a loop. So is the kth soldier alive? It's their turn to have the sword. And then is the nth soldier alive? N is the target. So initially we're looking 1 clockwise from the living soldier, and then we are going to find the next one that's alive. So when they find the living soldier, x of n, we're going to set to 0. Right, and then we are going to need to repeat this process here. I'll do this actually at the bottom. All right, so x of n, we have killed that soldier. So now k is the soldier we're going to pass the sword to. We're going to try the next soldier in line after the one we killed. So k equals n plus 1. And then we're going to do that in a circle. That's going to come up to the top. It's going to make sure that that kth soldier is alive. If not, then it's going to repeat this process. All right, so there was a lot of changing there that I was doing on the fly. So let's just see, again, logically how this works. We're going to start with this group of 5. They're initially all alive. Initially, the first soldier is going to have the sword. That's what K is representing, which soldier has the sword. N is which soldier is going to die next. So initially, it's the soldier 1 clockwise from the soldier who has the sword. Then we go into our loop. We're going to check how many soldiers are alive. Is it more than 1? If yes, we're going to keep killing soldiers. Right, who has the sword? So initially, we are going to seek the next soldier in the list to hold the sword. So originally k is equal to 1. So we check here, x of 1 is 1. So this while loop will never run. It will not run the first time at least, because a living soldier is holding the sword. So that's okay. Who is the target? I guess really I don't need this line of code up here because I'm repeating it in 38. So that will clean that up a little bit. All right, so initially we're going to try to kill the soldier 1 clockwise from us. So if the kth soldier is holding the sword, then n is going to be k plus 1. Right, then we're going to have this modulo in here to make sure that, like if the 5th soldier, if k is 5, n is going to be 6, but really it should go back to soldier number 1. So that's what lines 38 is going to do, is set 6 back to 1 or etc. All right, then we're going to make sure that that soldier is alive. So is x of, let's say initially, we're going to target the second soldier. Is x of 2 equal to 1? If it's not, we need to keep going through our list until we find the next living soldier. Once we find the next living soldier, we're going to kill them. We set that equal to 0. We set x of n equal to 0. Then we have to pass the sword to the next living soldier after that. So we're going to try 1 clockwise, and then it's going to go back here and seek the next living soldier. But again, once all but 1 soldier is dead, it's going to keep repeating this pattern. So I think this is going to work. Let's give it a go. All right, I did something wrong. Line 41. Let's see here. N is evaluating to 0. Let's see, why is that the case? K is 5, N is 0. Line 41. All right, I've gone through 1 round, so it should be soldier 5 is the one with the sword. So K is 5, that's correct. So N should be 1. Let's see why it is not. I'm going to put a break here just to see how is my code running. All right, so I'm on the first loop. Let me loop this. Okay, so the first round is done. It did it correctly. Let me go another loop. All right, we return to here. Now we have the second round. All right, so let's see what's happening. K is equal to 5. So the 5th soldier has the sword. That's correct. N is equal to 6. That's not quite correct yet. Oh, I see what I did here. That should be N, not K. All right, that's what was wrong. All right, now let's see if it works. All right, it doesn't crash. That's a good sign. And we go through the process. So soldier 1 kills soldier 2. Next round, soldier 3 has the sword. Soldier 4 dies. Next round, soldier 5 should have the sword and kill soldier 1. That's going to pass to soldier 3, who then kills soldier 5. So in order of killings, it should be soldier 2, then 4, then 1 is dead, then 5 is dead. And if we go through again here, 2, 4, 1, 5. So again, 2, 4, 1, 5. Let's just again see that in the code. So 2, 4, 1, 5. So yes, this is doing it correctly for the group of 5 that we were able to do on paper. And what I can do here at the end is it stopped the loop because only one soldier is alive. So I want to, now that I know only one is alive, let's see which soldier was the one that lived. So after I'm done with the loop, let me display which one was the one that survived. So soldier 3 is the one that survived. And just like we did on paper. All right, so this was kind of tricky actually to put together here, but it looks like our process is working in the small scale. So now we should be able to ramp it up. So notice in my code here, I didn't hard code in the number 5 anywhere, or I did it first and then I corrected that because in 22 now, but just by changing what big N is, I'll be able to run a larger scale simulation and I should be able to also get the correct results. So let me just space things out a little bit so we can tell what's going on a little bit easier. I think everything else looks, okay, do that. All right, we had a little bit of debugging to do because where I did like a copy and paste job, I missed that I was modding a K instead of N, but now all of that is fixed. Okay, and let me just change my indenting a little bit so it looks a little bit nicer here. All right, I'll run this again just to make sure it's still working. Okay. All right, so we've replicated what we did on paper. Now we are ready to see, was Josephus correct? Was the 17th spot the one that was safe? So again, in the story, there were 40 soldiers, not 5. Josephus wanted to live, so he figured out at which place he could stand. I've not run this yet. I hope I get the right answer, or the same answer here of 17. Let's see what happens if I ramp this up and make a group of 40 soldiers. Okay, thankfully, we got the same result, 17, as we got in the story. All right, so here it's printing out all of the steps here. I guess really I want to display the original group first. Let's just do that. Okay, so they're all alive. Then it's the first round, and soldier 2 is dead because soldier 1 has the sword, kill soldier 2. It should pass on to soldier 3. Soldier 3, that's going to be, it's a little bit tough to see here. Soldier 3 kills soldier 4, okay? It should pass to soldier 5, who's going to kill soldier 6. And that's right, it should pass to 7, who kills 8, so we should see a 0 next. Then a 0 here, and then a 0 here. All right, so that pattern continues. So it looks like we did do this correctly. We are getting that the 17th is the last soldier standing when we have a group of 40, matching the legend, at least as it's told here. So we have replicated the results. We've matched the legend of standing in the 17th position to survive, all of this through simulation. Now note, we could have done really a mathematical analysis and we wouldn't have needed to kind of simulate this one step at a time. We could know beforehand by just coming up with a formula that's going to tell us this. If you look up the Josephus problem, you can easily find the mathematical formula that's taking place. But actually a good thing to do, let me just get rid of these displays here. What we can also do is to get an idea of the pattern that emerges. Really what we might look at is, okay, what size group do we have? So what position should we stand in to survive? What we can do, since we have this all running in simulation, is we can keep running this with different numbers of soldiers, and we could build a table out of this. So with 2 soldiers, we want to be in position 1. With 3 soldiers, position 3. With 4 soldiers, position 1. 5 we already did. 6 we will be in position 5. Anyway, we can keep repeating this. We could put an outer loop also that is going to change the value of big N to build a table for us. And what that would let us do is build this table and analyze the pattern and come up with the formula. I'm not going to go through that for this example, but that's kind of the power of going through this simulation and what it can do for us. All right, so we were able to replicate our results. It was a little bit of a complicated problem to get going here. Again, probably not the most elegant solution to simulate this, but we do see that it is working correctly.